our page on like terms. So filling in the blanks here, like terms are terms that have the exact same variables, and the variables always have the same exponents. So the exponents are the little teeny numbers next to the variables that tell us how many times to multiply that number or that variable together if we knew what the number was, right? So let's start by looking at this first number here in the corner, 3x. It doesn't matter what the numbers are, other than the little teeny numbers, the big numbers in front called the coefficients. Those numbers don't matter unless, those numbers don't matter. It's just the letters, the variables, and the little teeny numbers, the exponents, that have to be the same. So what other terms in this list do you see that have a number and then just a plain old x? I see this one right here. There's no number in front of it. So when there's no number in front of it, what do we say that is? We say it has an invisible 1, if that's helpful later, because we're going to combine those together. Does that sound familiar? We don't always write the 1 when it's like that. Think of it this way. The reason we don't write the 1 usually is that, if you have an apple, you don't usually say, I have 1 apple. You just have an apple. So it doesn't. The 1 isn't needed. It's kind of just inferred because there's no number there. That doesn't mean it's a 0. It's there. The x is sitting there. It exists. There's 1x sitting there on our paper. Okay, here's another one right here. 4x. All right. So let's write down those like terms together. So we have 3x, and we have 1x, and we have 4x. And knowing that that's a 1x is important if I wanted to add our like terms together, because I would need to know that I'm adding a 1. So if I were to add those like terms together, what would it add up to? So I happen to do 3x. The instructions don't say this, but if I were to add those like terms together, I have 3 plus 1 plus 4. 8. Yep. Awesome. Let's pick another color. Here's just a plain old number. Do we have anything else that's just a plain old number without any letters? Yeah, perfect. So 4 and -3 are like terms. All right. What about this one? 10a cubed. Anything else that just has a cubed on it? Yeah, we've got 7a cubed. We've got a 4a cubed, and then we've just got that single a cubed over here, correct? So 10a cubed, 4a cubed, a cubed, and 7a. Those are all like terms. Let's see, how about this xy here? See how I'm using different shapes as well as colors? That way, if you're just using your one pen or pencil, you can kind of see a way to differentiate between them, even if you don't have different colors to use. So xy, any other terms have both an x and a y? Yep, we have our -4xy. And we have positive 2xy. So xy, -4xy, positive 2xy. So the cool thing about like terms is that we can combine them together, like I did the red ones. I combined them together. If they're not like terms, we can't combine them. They must be like terms in order to combine them. All right, let's go through our practice problems. So kind of the same idea. We've got to find the like terms and combine those together. And then anything that's not like terms with the others, combine either with each other, or if it's the only term like it, we just keep it in the equation or the expression like it is. Okay, so in this first one here, we have a 13x and a 2x that are like terms. So let's combine those together. So 13x and 2x combines to be what? 15x. Perfect. And then we have a 3y that doesn't fit. So we're just going to take the 3y and write it at the end by itself. There's nothing to combine it with. Now there are sort of some rules for writing down your terms. Usually we go in alphabetical order, so x comes before y. We don't have to do it this way, but typically just so that we have all of our answers in the same order so that it's easier to kind of coordinate whether we're doing things the same way. It's just typical to write in an alphabetical order with higher exponents first. You don't have to do it that way. It's just kind of a thing that people in math do. Okay, so x comes before y. So let's look at the next one. We have s's and y's. S comes before y. So let's look at our s's first. We have a 9s and a negative 3s. So we're going to take 9s minus 3s, which gives us what? 9s minus 3s. Yep, good job. 6s. Then we actually do have some other stuff we can combine here. So we have y and 5y that we can put together. So 5y and y, remember if there's no number, it's an invisible one. So it adds up to 6y. Good job. Okay, can we combine these together and make it 12sy? No, because they're not like terms. We can only combine like terms together. Even though they both have 6's, that doesn't make them like terms. All right. Next, remember how I said maybe do the higher exponents first? So we're going to do an x squared before just a plain x. So we have 4x squared is 6x squared. 4x squared plus 6x squared is 10x squared. See, we're just adding those beginning numbers and we're keeping the variable and the exponent exactly the same. It didn't change to x to the 4th or anything like that. Combine like terms. The like part of it with the variable and the exponent just stays the same. What goes next? Yeah. Plus 3y and then plus 5x. If I decided I wanted to keep it alphabetically, then I might do the 5x first and then the 3y. It doesn't really matter. But just plus 5x plus 3y. So I'm just so you know, it would not be wrong. It would not be wrong to do 3y 5x because addition is what we call commutative. It can move around and it still is the same. It doesn't matter what order we add things together. So we can do it alphabetically like this, or we can just do it in the order it appears. It doesn't matter. So this one was alphabetical. Recommended but not required. Okay. Is that just a minus 5? That minus looks weird to me. I think we'll just call it a minus 5. Okay. Let's go ahead and combine like terms in this last one here. This one looks a little bit crazy. What should we start with? The numbers, the xy's, the y cubes. Start with the one with the exponent, the y cubed. Cool, sounds good. So y cubed and 6y cubed. Did I miss any of the like terms for those? I think I got them all. So y cubed plus 6y cubed gives me what? 7y cubed. And then we have negative 3xy and negative 10xy. So which is it? Is it 7 or is it 13? And is it positive or is it negative? We have a negative 3xy and a negative 10xy. We're just combining the negatives together. Negative 13xy. All right, and then last we have 8 and 5 and negative 5. So that's kind of cool. Instead of actually adding it in our heads, we can go, oh, 5 and negative 5. That just cancels each other out, right? 5 minus 5. So just ignore the 5s. They go away. And then we can just have an 8 left over. Ta-da! Combining like terms. Not bad, right? Okay. I feel like we probably can handle doing distributive property. What do you think? This is pretty easy, don't you think?